All right, let's take a look at today's Aleks assignment. And I'm going to give this little example to you so that you'll know how to do each kind of problem. Yours will be a little different, but I think it'll be helpful. So on the first one, below is a table of values of a function, right? The output when the input is n. So if you notice, as we go across here, to get a 6 from this 3, I can either add 3 or I can double multiply it by 2. So we got to keep going across here and see what holds up. So if I add 3 to 5, do I get 10? No, I get 8. But if I multiply 5 by 2, I do get 10. So it looks like we're doubling the input to get the output. So down here, I'm going to just write 2 times x, or n. So excuse me, I want to put the right letter in there. 2 times n is how I get the output. So we check our answer. Sure enough. Okay, for problem number 2, we're going to look at these input and output or domain and range tables to see if it's a function or not. So to remember, when we did this in the past, we looked at the left side and make sure that all the letters are different. If they're all different, it doesn't matter what's on the right side, it is a function. On this next one, all the letters different once again. We don't worry about the right side. On this last one, or number 3, excuse me, the first letter is 0, 0, or the first number is 0 in each one, and each one seems to be paired with a different y value. So this is definitely not a function. And then on this fourth problem, K, B, E, N, all the first letters are different, so this would be considered a function. Okay, number 3. We have a relation which is a set of ordered pairs that we've talked about. So we want to find the domain of that relation, which happens to be all the first numbers or letters in that set. So, or all the x values, so that would be 1, comma, 5, comma, 3. And you notice that I hit the parentheses or braces before I typed it. On the next one, we want all of the y values, so 3, n, and n. 3, comma, n, comma, n. Now, Aleks might kind of get after me for putting n twice, even though you can see that there's 2 n's here. Sometimes it says you only have to write one of them. Okay, it was fine with it. It's fine, but there is no need to repeat the element in a set. So it was saying that I only had to write one n in that particular problem. Okay, number 4. We're going to look at all of these dots. Now you could write the coordinates of each of these dots over here, and then all the x values are going to be the domain. But what I'm going to do is I'm just going to look at the x value that they're lined up with. So this first one is lined up with -4 on the x-axis. So -4, comma. The next point clear over here is lined up with 2. So 2, comma. And then these last 2 points are lined up with the number 3. So I'm going to do 3, comma, 3. Now the range is all of the y values associated with these points. So for our left point up here, the y value associated with that one is 2. Then on our next one over, the y value associated with that one is -4. Then if I keep going over, these last two, well, the y value associated with this top one would be 1. And the y value associated with the bottom one, well, it's right on the x-axis, so that would actually be 0. So there's our domain and our range. Number 5. On this one, we're gonna type the word that describes the behavior of the graph between the 2 given points. So between A and B, it seems to be going up, so that would be increasing. Between B and C, it's trending downward, so that would be decreasing. Between C and D, that would be constant. And between D and E, it's also decreasing there. Number 6. Here's a function in slope-intercept form. We're going to go ahead and graph it. So our beginning value would be that -7. So we go down and click on -7, and our slope is to go up 2/3. And there, that should be the correct position of that graph. So let's check. And sure enough, we started at -7 and then up 2/3 for our slope to get a second point, and we are on track. Okay, for problem number 7, we are given a function that talks about the amount in dollars that this person needs after W weeks in order to get enough money to buy this TV that's costing them $500. So what we're going to do is we're going to keep subtracting off $17 a week until this gets down to 0, and then we'll know how many weeks it takes. So how much money does Lucy still need after 5 weeks? So if we put the number 5 into our equation, we are going to get 500 subtract 17 times 5. And it's not letting me put anything else in there. So it's times by 5, okay? So let's do that on our calculator. 500 subtract 17 times 5, and that equals 415. So after 5 weeks, she still needs $415. So if she still needs $177, how many weeks has she been saving? So if we put 177 up here where the A and the W are, then we're going to do 177 subtract 500, and that gives us -323, and then we're going to divide by -17. And that gives us 19 weeks. It's going to take 19 weeks for her to save enough money to buy that TV. Okay, number 8. This one employs the vertical line tool. So remember, if I draw a vertical line anywhere on the graph, if I hit the graph or more than 2 dots, if I hit the graph twice or more than 2 dots, it's not a function. So a vertical line anywhere inside that triangle is going to hit it twice, so it's not a function. Over here, a vertical line right here will hit this couple of these dots twice, so that's not a function. A vertical line will hit this V-shaped graph only once at any one point, so that is a function. This one, a vertical line would only hit 1 dot at a time, so yes. This one, you can see a couple of places here where these are overlapping just enough that a vertical line would hit more than once. So yes, that's a function. And then on this one, a vertical line will hit that twice. So that is not a function. Hopefully you remember. Oops, we missed one. What one did it say? Oh, this one we said that a vertical line would hit it twice. So that means it's not a function. I messed up on that one, didn't I? So recheck that one. That's better. Okay, number 9. We talked about whether a function is linear or not. You can tell if it's linear if you can put it into y equals some number times x minus 6. So this would be y equals 1x minus 6, or any other number, plus or minus. So yes, that's linear. This is y equals mx plus And since there's nothing behind the x, that means that the y-intercept must be 0, but it's still in y equals mx form, so that's a function. This next one has an exponent on the x, and that's a violation of the function rule, so it can't be a function. And the same with the last one, you got x to the y equals negative x to the third, so that's not a function either. So if we check our answer, that's correct, we got it right. Okay, so we go into the next one. All right, now in this case, we can state whether it's linear or not by just looking at the pattern. If it's got a constant rate of change, it's linear. So 4, 5, 6, 7. We're counting up by 1 on the x values. 0, -1, -3, -7. These y values are dropping more and more each time, so that would not be linear. Okay, on this next one, 0, 3, 6, 9, going up by 3 each time. And on the y values up by 5 each time, so we've got a constant rate of change. That makes that one linear. On this next one, the x values, you go to -1 to 2, that's up 3, up 3, up 3, so that's a constant rate of change. On the y values, up 3, up 3, up 2. So on that last one, it didn't quite make it, so linear, or not linear. On number 4, to go from -5 to -1, that's up 4 more, up 4 more. And the y values, up 4, up 12, up quite a bit, so actually not linear on that one. Okay. On number 11, we are asked to draw a line of best fit. And remember, we've been training you to use points on either end that are easy to use to find a slope. So I'm going to drop it right there at 32. Sometimes it's a little tricky to get to land right there. Okay, so now I know that my y-intercept is 28, and then my slope is down 28 and over 32. So on my calculator, I'm going to do -28 divided by 32. I'm going to get -0.875, but they want us to round it to the nearest hundredth. So -0.88x, and then my y-intercept once again was 28. And then I'm going to find out, I want to predict the time spent doing homework for a student who spends 18 hours watching TV. So I'm going to do -0.88 times 18, and that gives me -15.84. So when I add 28 to that, I end up with 12.16 hours. So let's check and see if we got that right. We did. So remember, when you do a line of fit, try to hit 2 endpoints that are easy to count down and over to so that you can use that to find your slope. Some of you might use points that are further up into the data, and that's fine, but I'm just trying to show you like a fail-safe method that will work. Okay, now we're going to skip that last problem because the last time I did it in this format, it locked up on me. So we're going to call that good, and you can, if you have questions, let me know about number 12.